Hi there, and welcome to this video about Solid Thinking Compose. Today we're gonna take a look at the 5th step of the 12 steps to Navier-Stokes. Let's get started. So we have here the 12 steps, step number 5, and it's linear convection, but in this case with 2 dimensions. So we have x and y, and we have derivatives, which we define with the Taylor expansion. And we have that for x and y similar to x. It's not listed here, but you can imagine. And we have this equation. So du dt plus c times du dx plus c times du dy equals 0. And then the normal stuff is going to happen. You have your discretization, forward in time, backwards in space, and you solve for your unknown, and you have some boundary condition, and then you solve. So let's get right into the code. I have a compose window right here, my Python code in here. So we have the boundary conditions. It should be familiar if you've done the steps before. Then we have x and y as vectors. Then we have a function, which is just ones with, in this case, a square. So an x in its width and y in its length. And we have that for un also, because that's our temporary array, two-dimensional array where we copy our values in. Then we have our initial boundary conditions. So we have ones everywhere, but we have twos in a certain space. In this case, it will be a square area between 0.5 and 1 in each dimension. And then we have our plotting. Note that we have another import here. And by the way, I forgot to tell you, it is necessary, maybe, for me it was, to update matplotlib if you want to use the color map function, because else it would give you an error. I just simply show that how you do that. So it's cmd, you change to your directory where Compose is installed. And then let's see, it's Python mpip install matplotlib -- upgrade. And it should say that it is already updated. So for you, maybe there's an update happening. And in this case, it searches for the most recent version of matplotlib. And then the color map should be no problem. All right. That being said, you have your color map with your axis 3D, and the plotting is done over here. So first we have a figure, and we define it by pyplot.figure, and we have a figure size here and the DPI here. Those values are optional. We define a projection 3D. And it's important to note that you have to use a mesh grid here. So x and y are now cannot be used with one-dimensional vectors anymore, but you have to do a whole grid. So with x and y's over the grid. You do that here with the mesh grid function. And then you just do your plotting with the surf equals axplot surface. Here are the capital letters. X and Y are used because those are referring to the mesh grid values. And here's your initial conditions, and here's your color map that you have pretty colors. So the initial conditions are shown here. And now you have two ways to calculate. Let me just quickly jump back to here. So the first way is to iterate with for loops. And as Python is not a compiled language, there can be a noticeable slowdown if you do that this way. So imagine you have a 2D grid, and you have to iterate over the columns and then iterate over the rows. So first column, next row, and the columns again. So that's your iteration. So for j in range 1 row, so that's the row. And here for I in range 1 column, that's the column iteration. And the column loop. And this is one way to do it. with for loops. Another way, which is a little bit better for Python, is to formulate this with arrays. And there, it's just a different kind of formulation, but it's doing the same thing actually, but much faster. And to indicate that, I have done a counter. So I have here a calculation with loops, and I set t equals time.time. And after I've done this calculation and showed the plot, I print the calculation with loops took blah 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 seconds. And the same is done with the arrays. So let's see how fast they are. Alright, I hit run. And it's running. And here we are. So this is the initial condition. This is after the time steps. And you see here, this calculation took 4.12 seconds. And here it's 0.5 seconds. So it's a noticeable difference between those two kind of operations. Alright, that's it for this video. Thanks for watching. If you have more questions about the code, feel free to go over to the MATLAB tutorial I've done. And also it would be really cool to, if you give a thumbs up or a comment on this section, and to just say what you want next, or if it's if you need more detail on a certain point or aspect. Thanks again, and goodbye.